Hi everyone. Uh, Today in this video, I'll be talking a little bit about different types of graphics cards or GPUs. So you might have heard of some graphics card which are good for mainly gaming, and there are some other graphics cards which are mainly good for creative works. Those are good for maybe video editing, or those are good for some scientific computing or any kind of graphics design or related work, right? So that means by the usage model, uh, we can know that there are two types of graphics card available to us, and it's better to know a little bit about them. Okay, in today's video, let's look at each of those different graphic types. For example, we can go to the website of AMD, and if you go to AMD's website, you can go to the product section. You will see the processors and then graphics, and in the graphics section we have some things listed there. Those are like workstation, embedded, semi-custom, laptop, desktop. So normally workstation is the category where which is mainly suited for the content creators, namely video editors, or you know um, graphics designers, or any kind of CAD, computer aided design tool, you know and CAD designers, or you can say, you know for mainly this workstation category represents that type of work. It can also mean scientific computing and things like that. And if you want to go for gaming, then most likely you should go to this desktop section. Let's first go to this workstation section, and if you go here, here it is listed that IBM is mainly having this Radeon Pro W6000 graphics series. And if you go down a little bit, here you can see, um, you know AMD has a Radeon Pro W6800, a Radeon Pro 6600, and Radeon Pro 6400 graphics cards. Okay, and here also, again, if you see, there are three categories displayed. Radeon Pro series GPUs for desktop workstations, and again for Apple, and the last one is for mobile workstations. Okay, if we go to the desktop workstations section, if we click here on learn more, here we will see some more details about this. And in this section you can see, again, these GPUs are divided into three categories. So heavy to extreme workloads, those are the ones which will be able to handle the extreme workload. Let's go there and check what we have here. So basically, some kind of basic description you can see. Basically, they are giving some valuable information about the GPU or the graphics card. We can directly go to the specification section, and here, this is the processor, you can say. um, AMD Radeon Pro W6800. So looks like this is the most powerful current generation GPU for workstation workload. And here you can see some GPU specifications given. So GPU architecture is AMD RDNA 2, then hardware tracing is there, lithography is TSMC 7 nanometer FinFET, ray accelerators 60, stream processors 3840, and compute units 60. And then you can see some peak half precision performance, single precision performance, and double precision performance number. Okay, those are some real good indicators to understand the performance capabilities of this particular processor. Okay, let's on the other hand, if you go to the same processor section again, sorry, graphics section again, and now if you go to desktop section, we will get to this particular page, and directly we can click on this specification section, and then we will be coming to this particular section here. Some of the top gaming GPUs are listed here, the models are listed here on the left side on the top. Here we can select RX 6900. Looks like this is the most powerful one. Let's go to the specification again, and here these are the specifications for RX 6900. And here if you see, the same specs are there: compute units, ray accelerators, then boost frequency, game frequency, and something like that. So these two things are at least different. We didn't see boost frequency and game frequency details in case of this workstation class GPU, right? So we hardly see anything about frequency here. Okay. And but on the other hand, in this gaming GPU, it has two frequency. So game frequency is 2015 megahertz, so that will be the normal game frequency. And when it needs some more performance out of the GPU, then it can boost the frequency from 2015 to 2250. That is the boost frequency. And apart from that, it has some other specs as well. For example, this one, peak pixel fill rate and peak texture fill rate, but those specs are not there in this particular GPU, and this is the workstation GPU, right? You don't see them, right? And on the other hand, here you can see peak half precision compute performance and peak single precision compute performance in this gaming GPU. We can see that. Okay. Here basically, if we talk about the precision part, so normally if you are from a computer science background, or if you know something about computer hardware, or at least how the you know um, how the binary system works to do certain tasks by the processor, then you should be knowing already that to represent some floating point character, uh, we need more resources. Resources is a, I mean, resource is a very big word, I mean, generic word. Basically, inside any processor, there are some, components called registers, or if you have studied in your school or colleges, those can be any sequential circuit, like a flip flop or latch. Okay. So normally, if you are dealing with an integer number, then we need a little bit less number of registers to represent that integer number. But if we are dealing with a floating point number, then to represent that floating point section or the precision section, we need some additional registers. Okay. And uh, again, like if we are only bothered about half precision, then we can manage with certain number of registers. But if we need single precision compute performance, then we will be needing more registers to represent that particular floating point number, right? So in case of gaming GPU, you can see we have only half precision compute performance and a single precision compute performance listed here. Looks like this GPU is not focused on getting high double precision compute performance, right? But on the other hand, here in this workstation GPU, you can see apart from having half precision performance and single precision performance, here the peak double precision performance is also listed here. Okay, so you can see half precision, that is FP16, single precision FP32, and double precision is the most precise one, FP64. So normally in scientific computing, or if you are doing any scientific computing, or if you are modeling very complex scientific uh, you know model or anything like that, there maybe we may need you know uh, more accurate calculations. Okay, and in scientific calculation, normally we have to deal with a lot of floating point numbers, right? And we cannot lose out on precision there. We need the most accurate values out of our calculation, right? And for this particular region, our GPU should be capable of handling double precision uh, numbers really well. And if you see here, as half precision performance numbers are good, it is 35.66 teraflops. But then again, if you look at single precision number, that is 17.83 teraflops. Now the performance is going a little bit down. And if you look at double precision performance number, that is 1.1 teraflops. Again, it is the performance is again, it has gone down further. So as I said, if we want to achieve more precision, we need more number of registers to achieve that. And if we need more number of registers to achieve that, or in other words, if we need more resources to represent or to implement any FP64 calculation, then we have less resources available for other calculation or other instruction, right? And that is why you can see when the precision increases, the performance of the GPU also decreases, and that is what is happening here. So single precision performance is 35 teraflops, but double precision performance has gone down to 1.1 teraflop. And this double precision performance numbers are really important in case of scientific calculation, and that is why you see that in W6800 graphics card. So, but on the other hand, in case of gaming, yes, we need some kind of floating number based calculation, but it's not that much. Normally when you play any game, basically, while playing game, you get some frames at a very high speed. So mostly uh, you know uh, for high speed frames, you need high gaming frequency. That is why you can see they are putting more focus on gaming frequency here. And those frames are nothing but uh, a frame of you can say pixels. And each pixel is the very basic building block of any photo, you can say, right? and and each pixel can be represented by certain bits. All right, and for example, let's say if my pixel can handle 256 different values, okay, that means by manipulating the bits of a pixel, I can get 256 color combination. All right, so to represent 0 to 256, we need some amount of bits. All right, that is for integer number. But now on top of that, if we are now uh, if we are like now again focusing on floating point numbers, then that is an added workload. Okay, to represent that floating point section, we need more resources. But in case of gaming, mostly it is about the frames at high speed, so high frequency is a must. And then individual pixels can be normally represented in certain number of bits, and depending on different you know uh, combination of those bit values, you will get different colors. That is one thing. Of course, there will be some kind of you know processing happening uh, in those frames, and there may be some kind of calculation will be needed, and those calculations will involve some floating point numbers, right? And to represent floating point numbers, we will be needing more resources of the GPU, but that is not as high as what we see in workstation class GPUs, okay, in scientific computing. So that is the main reason I can see. In scientific computing, the main focus is to get double precision performance, but in gaming GPUs, the more focus is on to getting high frequency, so that more number of frames can be processed at a certain time, and that is what you are seeing here. Okay. I hope, I mean, this is not a very professional sounding explanation. um, so I had some information about these two types of GPUs. That's why I thought of sharing this to you guys. And in future, if you guys want to know more about on this topic, please let me know in the comments, and I'll see you guys in the next video.